Hello, can you hear me? Hello. Okay, so good evening, everyone. So, can you hear me?
Yes.
Okay. Okay, so we are waiting some time for joining all of the participant. Then we also try to start our today's class. Okay, so now we will start our today's session. So basically, we will complete it our total 3 days online training program. So today we will start our fourth number of class, and basically, okay. So I simply share my screen, then try to start. I simply share my screen. So now, can you see my screen?
Yes, sir.
Okay. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis for beginners to advanced level. So basically today is our fourth number of day, and today I will try to discuss about all of the content. So I just simply share my all of the content. Sorry for this. This side is not slide. This slide is not. Okay. Okay. So these are full course content. Total 7 days. And today is our fourth day. So this course content will be that. First of all, I will try to discuss about that how you can easily remove the cloud or haze from your satellite images, and then get a very clear satellite images. Okay, so how you can easily get this very clear satellite images. Suppose when you want to work with the rainy season or wet season, then you can find out the some cloud. Okay, so that's why in this time I also try to discuss about that part, how you can easily remove the cloud from your satellite images and get a very clear satellite images. Then we also try to discuss about that DEM data. So this is the digital elevation model data. How you can easily use this data and make the different types of map, hillshade map, salt map, aspect map. We also try to discuss. We also try to discuss about the land surface temperature monitoring from MODIS satellite imagery and make a time series chart of the land surface temperature so that we can easily find out the temporal changes from the chart. We also try to discuss about that how to calculate the average, maximum, minimum, NDVI or anything. Suppose you want to identify for suppose any region such as Dhaka city, you want to find out the average, what is the average NDVI or what is the average LST or what is the average maximum NDVI. How we can easily get this type of value. We can also try to calculate all of the average, maximum, minimum for any specific region. It can be NDVI, it can be LST, it can be any indices or anything. How you can easily get this? We also try to discuss about this part. So mainly how to remove the cloud from the satellite images. So mainly when you want to work with the rainy season or wet season for any satellite image, then you can find out some cloud and haze from your satellite images. Such as in this time you can see this is a satellite image. Here you can see this satellite image. We can find out the some cloud. Okay, this white pixel value is identify the cloud. And when I want to use here the cloud marks band function, then I can get very clear satellite images look like this. Okay. And so in this time I try to show you this practically. So I try to make the cloudy satellite images for a rainy season, and then how can easily remove the cloud from the all of the white pixel value mention the cloud. How can easily remove the cloud and then get the clear satellite images. So I simply open my slide, open my code editor. Okay, so I simply open my code editor here. Okay, so now you can see here I get this my code editor. So in this time I want to work with the suppose Sentinel-2 satellite imagery. Okay, so for this I simply search here. Okay, or I simply go to the browse data catalog for find out this Sentinel-2 satellite imagery. I simply click on the Sentinel. So I want to work with the Sentinel-2. I want to work with this top of atmospheric. Okay, so if you want you can simply copy this artisan snippet from here, as well as if you want you can simply search the top of the code editor, such as I simply search here Sentinel. So now I simply open this. Okay, so you can see this is my satellite images. I can simply import this. So now this satellite image is imported in my code editor. Okay, and then okay, so I also, so in this time I think my some technical issue, so it takes some the loading and I did not write the code very fast. So okay, so okay, in this time I also import my shapefile. So I simply go to the asset tab, and from the asset tab I simply import my shapefile. Suppose I want to, so I simply import the shapefile of Dhaka city boundary and put this variable name such as RY. Okay, so in this time I just filter these satellite images. So we already discussed about this part, how you can easily filter the satellite images from the Landsat or Sentinel. We also try to discuss about that. in this time I use the same code for filter bounds, filter date, filter metadata. Okay, then I simply filter this image collection and get the satellite images. Okay, so let's go. If you can see image collection, if you want you can simply change the name or not, it's totally depend on you. So I simply change the name and put the name, suppose S2, okay, S2A. You can put any name, no problem for this. So in this time I want to take a variable name. I take this variable name and so it's worked very slowly, so sorry for that. So I simply take a variable name such as I put the this image. Okay, take the variable name image. Okay, then I simply call my collection name S2A. This is my collection name S2A. I simply call this collection name, and first of all I simply use here the filter bounds function. Okay, then I simply put here this my region of interest. My region of interest is that ROI. Okay, then I simply take the another, suppose I simply use here the filter date function and put the specific date such as 2016 1st January from 2016 December 31. Okay, and then I also simply put here the another thing is that if you want you can use here the filter metadata metadata, and then simply I want to go to this image properties. So image properties and select the cloud pixel percentage. Then copy this properties name and simply paste here. I simply paste here. Okay, then I simply set the name is that, suppose I set the operator less than, suppose less than 1. Okay, so this is the one method for filter metadata function. If you want you can use the another method such as I simply use here the filter function. Then I define how I can filter. I want to filter Earth engine filter dot less than LP, less than. Okay, then I simply put here this cloud pixel percentage and set the value, suppose 1. Okay, so in this time you can see if you want I want to filter the same work, suppose filter metadata, you can see I can simply use here the cloud pixel percentage less than 1, or if you want you can simply use here the filter function. Then how you can filter, you want to filter Earth engine filter dot less than the same. Okay, so in this time I want to filter this image properties, and after this I simply use another thing is that all of the images I want to create the median function, median. Okay, and then it also clip with my shapefile. I simply use the clip my shapefile is that ROI. Okay, then I simply show the result of the image. So I simply use the map dot at here, and then simply call this object name image, and paste here and click to the run. And I also need to set here the map dot center object and call my ROI and put here the suppose 10 and click the run. Okay, so now you can say I can get the result look like this. Okay, and I want to set here the band visualization from here. So I simply click on here and set the band such as band 4, band 3, band 3, and band 2, 98% stress for better looking. Then I simply use the apply. Okay, so this image we did not find out the so much cloud. So I simply also increase the this value. Suppose in this time I want to add the value for the 90%. So I simply use at the less than 90%. So 9 and click to the run again. Then I simply click to here and then check again B4, B3 and B2 is at 98%. Apply. Okay. So now I can see I find out some cloud is satellite images. Also find out some haze. Okay, so you can see we find out some cloud, the white pixel value, this cloud, and also we can sum out some haze on the satellite images. So in this time, my main target is that I want to remove all of the cloud and haze from the satellite images. Okay, so for this, so I simply imported the visualization parameter and simply copy this and paste after the object name. And put the layer name, suppose cloudy, like I put this name cloudy. So now it's set it. So in this time, my main target is that I want to remove all of the cloud and haze from the satellite images and get a very clear satellite images. Okay, so for this, okay, so in this time, this satellite image, all of the satellite image has a function band. It's called the cloud marks band. Okay, so in this time I simply go to this band and check all of the information about this band from here. So you can see in this time, you can see QS60. Okay, this QS60, this is the cloud marks band. Okay, and this QS60, this band has a 2-bit. You can see bit 10 and bit 11. We can get the 2-bit. Okay, so here you can see the 2-bit has some also sub bit 0 and 1. 0, it means that no cloud, and 1 is means that it cloud present. Also you can see 11 is that we can see the 0. 0 means that there is the no cirrus cloud. Okay, and 1 is means that the cirrus cloud. Okay, so in this time we make a function in our code editor. In this function we want to first of all just we can select the QS60 band. This QS60 band we select. After selecting, we also select the bit 11 and bit 10. Bit 10 and 11 also select. After this we also select the bit 0 and also set the bit 0. Okay, from the bit 10 select the bit 0, from the bit 11 select the bit 0. Okay, then we can get the clear condition of the satellite images. It means that there is the clear condition of the satellite images. There is a no cloud and there is the no cirrus cloud. Okay, so in this time we create a function, so and select the QS60 band. So I simply copy this band name from here, because with this band we also need. In this time I create the function. So I simply make a function. So I simply put the function and put the function variable name. Suppose marks to clouds. Okay, and then I simply use the parenthesis and put here the element name, suppose image. Okay, after this you can say I simply take this function. So this is the one way, and then simply use here the parenthesis, and this parenthesis we can use our argument. Okay, in this time you can say I simply create the function. This is the one way for structure of the function. If you want, you can also use here the another way. This way is that if you want, you can also use here the var keyword. After the var keyword, you can simply look like this structure. You can simply take a variable name, suppose marks to clouds, marks to clouds, then use here the equal sign, and then use here the function, then element name is the image, and then simply put here the curly bracket, and in this curly bracket you put your argument. Okay, so this is the another way. So if you want, you can use for creating the function. Okay, so you can see I can simply put your all of the argument in here. Okay, so if you want, you can follow the follow this structure, as well as you can also follow this structure. Okay, so all of the things will be same. So in this time we can see, if you want, you can use this, no problem, or if you want, you can also use this, no problem. Both of things result will be same. Okay, oh, in this time I simply use this function, so I simply remove it. Okay, so I simply create a function, also create the function variable name. In this time I need to select the QA60 band. Okay, so for this I simply take a variable, then put the variable name is the QA. So it's very disrupting for this very slowly working. So after this content, I just simply take the 2 minutes for restarting this laptop again. Then I hope it will be not happened. Okay, so otherwise it sometime it also loading, or we can see we can get this. So I simply take the variable name is the QA. After this I simply call my element name image. Okay, image, image, then I simply use the select function, select. Okay, and then select the band is that QA60. I select this band. So band name is the QA60. I simply paste here. Okay, so you can say I simply select my band QA16 here. After this, in this time, in this band has a 2 bit, bit 10 and bit 11. I also need to select this. Okay, so for this I simply take a variable, and put the variable name, suppose cloud bit, cloud bit marks. Like we can use any variable name. Okay, then I simply use here the 1, and then use the less than, and then select the bit 10. Okay, so because we can get the 2 bit cloud and cirrus, bit 10 for the cloud and bit 11 for the cirrus. So I simply take the another variable. So, and this symbol you can see less than, when you want to define any bit, we are using here this less than. and then I simply use here this, suppose Siras bit marks, and then use here the one less than suppose 11. Okay, so I simply select the two bit 10 and 11, and after this I need to set this bit 10 equal to 0 and this bit 11 equal to 0. Okay, then we can easily update this marks and add this. Okay, so for this I simply take the another variable. Suppose this variable name is that mark, and after this you can use any variable name. I simply use at the mark. Okay, and after this I simply call this band QA60. QA60 is stored in this variable, so I simply call the QA60 or QA, this variable name, and then use at the function bitwise and function. So mainly when you want to, in this time, this is my band QA60. From this band I want to select a bit 10. Okay, so in this time, for this connecting the with my band and bit, I simply use here the bitwise and this function. Bitwise and this function I add. So it take the time for the loading, just a minute. So after completing this content, I will just simply restart this and then try start the class again. So otherwise it's not work properly. So bitwise and, okay, bitwise and then I simply call the cloud bit marks. Okay, simply copy and paste here. Then I simply set equal to 0. Okay, so I simply set eq means equal to 0. So I simply set the equal to 0, and then another Siras bit marks. So for this and I simply use here the and function, and I simply call the QA here the store at the QA60 band, and this QA I want to add the bitwise and function, and then in this time I add the Siras bit marks. Okay, so I simply use the QA. I simply call this QA. This is the QA60 band, and in this band I need to add the Siras bit marks. So it working. Okay, wise and, okay, then I simply call the Siras bit marks. I simply copy and paste here, and then set equal to 0. Okay, so in this time I will again explain this code. So first of all, you can see in this time we are using the Sentinel-2 imagery. So in this time this Sentinel-2 cloud marks band name is that QA60, and this QA60 band has a 2 bit 10 and bit 11. In this time my main target is that from this band I select the bit 10 and set equal to 0, as well as also QA16 band I also select the bit 11 and then set equal to 0. So it's identify the clear condition of the satellite images. Okay, so in this time I use here the update marks function. Okay, because all of the things I want to add with my update. Okay, so for this I simply use a return function in here. So all of the things I want to return and add with this update marks function. So for this I simply use at the return and simply call this element name image, and then I simply use a function. It's called the update marks. So this image, in this time I had the update marks function. Then I simply set the what is the update marks value. I also set this value. So just a minute. Okay, so I simply use here the update marks. and then I simply use here this, you can say update marks, and now I want to set the variable name. Okay, in this time you can see I set here the QA, this the QA 60 band equal to 0, then QA band 11 I set the equal to 0. All of the things I want to store in a variable. This variable name is the marks variable. Okay, so in this time I update my image according to the marks variable, because all of the things is stored in the marks variable. So I simply copy the variable name marks, I simply write this marks, M-A-S-K, marks. Okay, so now it updating with this marks. Okay, so in this time you can see this is our function. Okay, so this is our function I created for set clear condition of the satellite images. In this time when I add this function with my image collection, then it will be remove all of the cloud and haze. Okay, so in this time I also take the another layer. I want to show the two layer, suppose cloudy image, as well as also I want to show the another image for the cloud free image. Okay, so in this time I simply copy the same code from here. So I simply copy the same code from here. Simply copy, okay, and paste here. And just I simply change the name. Suppose image. So I simply put the image is the. So I simply put the image is the suppose. Yes, clear. So I put the image name image clear. Okay, then all of the things will be same. And then I simply add this function variable name with my image collection. So I just simply write this function name in here. So I simply use at the map function, map, and then simply call this function variable name. Function variable name is the marks to cloud. I simply copy and paste here. Okay, marks to cloud. And then to show the result, I simply copy this object name and paste here. Okay, then I simply use here the cloud layer name, suppose cloud free image. Okay, then click to the run. Then we can check what the difference we can get after adding the cloud marks band function. So then click to the run. So this is a cloudy image where you can find out the cloud. You can see white pixel cloud. Okay, so now you can check. This is the cloud free image, the and his image. When I simply compare, you can see the first layer is the first image, the cloud free image. So you can see the cloud image. I can when I use the cloud mark band function, you can see I can get. You can see I can get the some cloud in here. I also zooming. You can see. Okay. And also haze. Okay, so you can see when I want to simply open the cloud free image. So now I can see. I can get the clear, and there is a no cloud in here. So you can see this is a cloudy image and haze. When you can see all of the haze, you can see also I can get the some haze. All of the image, this is the haze. And when I open this, when I apply the cloud mask function, I can get the very clear satellite images. And now I can easily identify all of the things. And this image is the properly used for making the land use land cover classification map. Because in this time you can see when you want to work with the cloudy image, you can see this cloud pixel value is mixing with the build up feature or mixing with the barren land. Okay, so then we did not get the proper land use land cover classification map. Okay, so when you want to make the land use land cover classification map and you can find out the cloud look like this, you must be remove the cloud, then make the land use land cover classification map. Otherwise we did not get the proper result. And this is the process for making the removing the cloud and haze from the satellite images and get the very clear satellite images. Okay, so anyone any question about this?
Yes,
Yeah.
Rahman, the syntax of the function, can you please more clarification? For
Okay.
example, less than, what does it mean?
Okay. So basically this is the symbol. In this time I need to select the bit. You can see. Okay, so just a minute. So mainly when you want to select the bit, so in this time all of the bit will be start from the 1. Okay. So in this time I select the 1 and then user the less than 10. So this is the sign. Okay. So mainly when you want to select the bit, we need to have this sign, we need to use less than this sign. Okay. Not only for the in this function, suppose you want to work with, you can see it's a symbol. Okay. Suppose in this time I want to select the bit 10. So that's why I simply use this sign less than and also use this sign. Okay. Okay, so it is a
It's
symbol.
like to attribute. It's like to attribute.
Yeah.
Mm-hmm.
Yeah. Then you can use this then and store it this variable. Okay, and after storing this variable, you can see I simply call the QA. QA is the QA60, and QA60 in this time from the QA60 I want to select the specific bit. Okay, so that's why I simply use the bitwise and then simply copy this variable name cloud bit max. Okay, then sets equal to 0. Okay, at the same process away for the slash bit max, I simply use the QA, then use the bitwise and then simply call the slash bit max. Okay, so you also try to do for your own self for using the land set, removing the cloud from the land set. Then I hope you can easily get. And then I also put the some homework in this time for this. You can also remove the cloud and haze from the land set surface reflectance satellite imagery. Okay, so I also show you this
but what
images.
Does it mean?
Yeah.
Sorry, Rahman. What does it mean? Bitwise and this.
Bitwise and is a function. So mainly when you want to, suppose you can see QS60. This is a band. Okay, in this band has a 2 bit 10 and bit 11. In this time from this band I need to select the specific bit. Okay, so it's not a band. Okay, in this time from this band I need to select a specific band. Okay, so that's why when you want from the band when you want to select any bit, we need to use a function. It's called the bitwise and. Okay. Okay. Yes. The same way, suppose in this time when you want to mainly we are using the select function when you want to select the band, but in this time it's not a band, it is a bit. Okay, so
in case of band we say select, for example, as we did.
Okay. Yeah. Okay, and you also try to for your own self. I also put you the show you the satellite images. So suppose I simply go to this data set and then go to the land set. Okay, so you also try to remove the cloud from the and haze from the satellite images. Then if you are not face any problem, then I also try to show you this part also for the removing the cloud and haze from the satellite images. Surface. Okay, so you can see in this time this bad name is the QA pixel. Okay, but when you can see the sentinel, you can get the QA60. In this time you can see it showing the lot of bit. You can see bit 0, bit 1, bit 2. Bit 0 is the fill. Okay, then cirrus cloud shadow snow. Okay, also you can see water. Bit 7, also you can see bit 7 the clear. It bit 6 has a 2 also some sub bit 0 and 1. Also you can see cloud confidence. Okay, so you also try to do for your own self for removing the anything, suppose cloud or water or cloud shadow. Okay, Then if you don't do this, then I also try to show you this part, how you can easily remove the cloud and haze or cloud shadow from the land surface, Landsat image, surface rectangular satellite image array. So I also try to show you the later, so how you can easily do this. Okay, so you also try to for your own self, then face any problem or not working, then I also try to show you the proper method. Okay, so anyone any question? Okay, so in this time I just get the code link button, and I also take the some 2 minute break. So for I in this time I think there's a lot of tab is opening in here, also a lot of file opening in it, so that's why my system is also working for slowly. Okay, so that's why I simply restart my system, and then joining again. Okay, so just a minute, I simply restarting this. It worked very slowly, so I just simply okay, so just 2 minutes, I simply restarting and then joining again.